Hi, I'm Ryan Nichols, CTO at DSA Ocean, and today I want to talk about starting an analysis straight from a dynamic export in Oceanographic Designer. So what we're talking about is, rather than doing a static analysis first and resolving the static profile, just jumping straight into a dynamic analysis. And when would you want to do that, and when is it important? Well, it's important to consider a static analysis when you're looking at something like the soft mooring, which is in full ocean depth. It takes quite a long time for such a long mooring, that's 6,000 meters long, mooring line in the water, to get to its steady state position. On the other hand, much shallower water moorings, or moorings that are very light, actually just naturally reach their steady state profile pretty quickly. So an example of this is the SOFAR spotter template mooring that you can see in the sample files we have available. It's in 50 meters of water depth, which is, it's not insignificant, but it turns out that it's a pretty good example to check out for this. So what I've done is I've opened the SOFAR spotter mooring file here. You can see that we've got a pretty low current profile, 0.3 meters per second. But rather than do a static analysis, we'll just jump straight to a dynamic analysis. And the nice thing about this is that you can go a little bit faster. You can jump straight to the dynamic analysis and characterize the loads a little bit faster than going through the process of doing a static analysis. So what I'm going to do is I'm going to add some John swap irregular waves, right-click, resolve follower properties here, and we'll just set the wave height to 5, and we'll just change this to 200 seconds. And if you look at the starting condition of the mooring, what is happening here is the starting condition is just a straight diagonal line from the anchor. It's totally arbitrary, just to give it some starting state. This is what would go into the static solver and the static solution process normally, and then it would resolve a relaxed profile of this line. But the motivation here is that you got a little bit of a current profile, and once you start seeing wave motion, you'll see the system relax quite quickly to a reasonable, approximation of that. And then the dynamic loads don't really change too much, and you can justify doing that. So what we'll do is we'll run this here. And what we're going to do is just let it run for a bit, and we'll check on it through the course of the analysis and just see what it looks like. All right, so we actually got the whole thing to completion here, and let's just take a look at the results. So we'll open ProteusDS. And rather than, we'll just load the whole thing. Might take a little bit of extra time. Oh, it's not too bad. All right, so here we have a rendered view of the system. And it's a little bit easier to see things again in engineering view, so we'll just switch over to that. Okay, so maybe we'll show tension here as well. Tensions are always going to be very low with these small buoys and fairly low tension moorings. So yeah, part of it's also checking the loads and the motions, but also you want to keep an eye on submergence as well. It's just as important to check for data quality and continuity of data as well. But my main point is, so even starting off with a diagonal line, if we just hit play, right off the bat, you can see there's two mid-water floats. These are just little plastic trawl floats, but we're not even in 10 seconds in the simulation where we have the waves ramping up, and the floats are pretty well relaxing the system into what looks like a reasonable kind of approximation of that steady state profile. So, this is just an example of showing how relatively shallow water moorings you can get to a really good profile really quickly. And really it justifies jumping straight into dynamic analysis, and you save a bit of time in just quantifying what's happening and verifying the motions of the system. So it can save time and just make it quicker to get through the analysis process. But of course, use your judgment. Thanks for watching.